All right, this is number 35 on page 155, which is lesson 3.7. We're going to use implicit differentiation to find the derivative, then write the equation of the tangent and normal lines that touch the curve at the point 1, 0. So to find the derivative, I'll do the derivative of y, which is dy over dx. Here I've got multiplication, but I see a constant to the left, so I don't have to use the product rule. I can just copy down the constant of 2, take the derivative of sine, which is cosine. But I'm going to have to use the chain rule because I have the sine of this expression. So the chain rule says I do the derivative of sine, which is cosine, and I copy down the inside information, and then multiply by the derivative of that information. One thing you have to be careful of, you have to make sure you put that derivative in parentheses. So derivative of pi x would just be pi. The derivative of y would be dy over dx. At this point, I can either solve for dy over dx, or I can go ahead and plug in the 1 and the 0 right away. I think it's probably going to be easier to plug in 1 and 0 right away for x and y. So that's what I'm going to do. So I'm going to have dy over dx equals 2 times the cosine of pi. And for x, I'm going to plug in 1. So times 1 minus 0 times pi minus dy over dx. So this is going to be the cosine of pi. Cosine of pi, we know that pi on the unit circle is right there. Cosine is your distance left or right, so the cosine would be negative 1. So this is going to be 2 times negative 1, which is negative 2, times pi minus dy over dx. Now I'm going to have to distribute the negative 2 through. Multiply it times each of these things in the parentheses. That's why it's so important to put that derivative in parentheses, otherwise you won't know to distribute that through. And that'll give you dy over dx equals negative 2 pi plus 2 dy over dx. Now I'm going to subtract 2 dy dx off both sides, because I really want to know what 1 dy over dx equals. If I do that to both sides and bring that answer up here, we can see it better. This is 1 dy over dx minus 2 dy over dx will be negative 1 dy over dx. So you can think of dy over dx as kind of an object. It's like you're subtracting 1 apple minus 2 apples would be negative 1 apples, that type of thing. Equals negative 2 pi. Right here. This is gone because I subtracted it over. Divide by negative 1 on both sides. Dy over dx equals 2 pi. That's the slope of your tangent line. So to write the equation, I'm going to use point-slope form of linear equation. I'm going to take y minus my y coordinate of 0 equals my slope of 2 pi times x minus my x coordinate of 1. I can distribute the 2 pi through, and I get y equals 2 pi x minus 2 pi. That would be the equation of the tangent line. Get the equation of the normal line, I just simply change the slope of 2 pi to its opposite reciprocal. So I'm going to have y minus 0 equals, this opposite reciprocal of 2 pi would be negative 1 over 2 pi times x minus 1, which if simplified would be y equals negative 1 over 2 pi x minus, actually negative times a negative, that would make that plus 1 over 2 pi. That would be the equation of your normal line.